Okay, we're here with Mrs. A. I have another experience on how we solve polynomials using heuristics. Okay, so let's take a look back at what we've learned so far in our prior experiences. We talked about how we can use the standard process for problem solving that we learned back in 5th grade. The understand, plan, try it, look back. We've all learned this. We've learned how we can use this for polynomials. This is Polya's problem solving process, and I'm sure you're familiar with it. And if you haven't seen the other experiences, I'm sure you can still hop right in and understand how this can be used to solve polynomials. So for the understand phase, we solve a polynomial by first understanding it. We talked about how we look at the solution set, the degree, terms, coefficients, and the ask. And then we can move on and plan. Using our own experiences and our understanding of that polynomial, we plan the best approach to solve it. Then we can take that approach and use the steps, substitute the variables and values, we simplify and solve. We make sure we are answering the ask, and all along we're monitoring our efficiency and accuracy. And then once we're done, we take a look back at our work, we compare it to the solution, we compare it to other approaches, and we look for what worked and what didn't work. So it's that standard process. I'm sure you're all familiar with it. Again, it was in all of our textbooks back in 5th grade, but we can actually use it to solve polynomials. So today, where I wanted to focus in on is that statement in that plan phase. We plan the best approach to solve it. Now, if we're really lucky, the plan just comes, straight to our mind when we're trying to understand the polynomial. The approach just pops out at us. But what do we do when we're not lucky and we're not sure how to move forward? That's what we're going to cover today. Now, why can planning how to solve a polynomial be so hard? We started, let's say, learning x squared minus 4 is equal to 0. And maybe initially we learned the square root method. We learned how to factor, difference of two squares. And we keep learning these new methods like completing the square, quadratic formula. And it gets to the point where we're not sure when to use which method. And the problem is just that there's just too many methods. And then what happens is maybe a teacher mentions, well, the quadratic formula can be used to solve all quadratics. And that's not a great answer either, because one approach is not a fit for every problem. Algebra was never intended for us to just memorize one formula and it gets to the point where we're memorizing 101 formulas. We're supposed to be doing this through our own reasoning, building up our logic through our own experiences. And, we have to be able to take any problem. And sometimes there's outliers, and sometimes we have to be able to make tweaks. So one approach is never going to fit. Now, I can even give a very practical example here for x squared minus 4 is equal to 0. And I've seen students do this. They take the quadratic formula and they apply it and they get the right answer. But along the way, there's radicals and fractions, and there's a lot of room for error and lack of efficiency. But if they had looked at the problem and they noticed that the method that they could have used was difference of squares, well, now they could have done it mentally and had the answer without any room for error. Now, the thing is, though, how do we take all those methods and how do we come up with the reasoning that we need to be able to select which method to use when? And so just like I always appreciate Polya because he was a mathematician and he provided all of these tools for his students because he wanted them to become better problem solvers. And so he had that, understand, plan, try it, look back approach for them. And he had a bunch of other tools. So I'm always asking, well, what would Polya do if he had to try to come up with a plan to solve polynomials? And, what he would say is heuristics. Now, I know you don't need another vocabulary word, but heuristics is really simple. This is just those rules of thumb that we use in our lives for making decisions efficiently and accurately. We can actually use this for polynomials too. But let's think about how we use them in our own life. Pause the video for a second and think of some of the rules of thumb that you already use in your day-to-day life. Okay, so I'm thinking about, in my life, a couple of the rules of thumb that I use. If I want to make a change in my life, I need to repeat that change for 20 days, and then it becomes habit. Another one I'm thinking, in my math business, if I want to sell $100,000 of math services in a year, well, I'm going to have to go out and try to sell $300,000 just to close on $100,000. Another one, I was just the other day when I was my son's tennis racket, the strings needed to be replaced. And so I asked his coach, how often should I be replacing strings? And he had a rule of thumb. It was, if your son practices 4 times a week, replace the strings 4 times a year. Well, share some of the rules of thumb that you use in your life in the comments section. I'd love to hear them. And let's see how this applies specifically now to solving polynomials. Well, what we would do is we would be given a problem like x squared minus 4 is equal to 0. And again, if we're lucky, the approach just comes to us. But if we're not, what we would do is we'd look up in the heuristics that we created and see if anything would help us solve it. So maybe we have a heuristic that we came up with, which is, when there are perfect squares, try difference of squares. Well, when I look at this problem, the x is a perfect square, it's x squared, and the 4 is a perfect squared, it's 2 squared. So I would know to use difference of squares whenever I see this type of problem. I'll get a little bit more into detail. So let's start off with how do we create the heuristics? Because to use them, we need to create them, and they have to be from our own experiences. So the process is really easy. It's observe it, create it, use it. Observe it, we do this through lots of our own experience and practice. Create it, we just, from that experience, we define when do we use it, what do we do, and we give it a really great name that we're never going to forget. And then we have to continuously use it and improve it as we're using it. And if it doesn't work, we just can it. So just remember, though, the reason we're creating these heuristics for ourselves is so that we can avoid hard work. We're not just doing this because Mrs. A says it's a great thing to do. Always try to keep that goal in mind. So let's give this a try. So I did a whole bunch of difference of squares problems last week, and probably about 20 of them. And what I noticed is whenever I was solving difference of squares, that my efficiency and accuracy was really high when I used this method, and that I could actually solve it mentally. And I started to think about, how do I notice a difference of squares problem? And I saw that, well, it was pretty easy. The variable and the coefficients were both perfect squares. And the other thing I noticed is this is almost like an anti-heuristic, but I keep it in here to keep this in mind, because when I'm solving these type of problems, if I sometimes think that there's an identity called sum of squares, but there isn't. And the thing I do is I solve those type of problems using the square root method. So that's my experiences. You'll have your own experiences when you're thinking of difference of squares. Now, what do I do with that observation? I create a heuristic off of it. So based on the criteria, we said that the coefficients and variables are perfect squares. That's when we do this. We define what we do. So when I looked at my observation, I thought, well, what I want to do is I'm going to solve it mentally, remind myself that I got it, and I'm going to use difference of squares. And then I put that extra note, never use sum of squares. And then I gave it a great name, and it's perfect squares needs difference of squares. And I put it into my list of heuristics. Just an extra note is you can put a link right into the heuristic, or you can add in the steps right in the heuristic so that you quickly know, once you've chosen this as your planned approach, what to do next. All right, so that was created. Now we're going to use it. So the first step that we do for using it, we're going to do our normal plan stage where our normal understand stage where we're going to understand the criteria and the constraints of the polynomial. And then we're going to get to that next stage of justify a plan. And that's where, if we're not lucky and the answer isn't obvious, that's when we pull out our list of heuristics. And we're going to take a look at them to see if anything matches those criteria and constraints from the understand stage. If there is, then we have our plan, we get the steps, and we put those steps into the solve it stage. And then when we're done, we look back and we look at the answer, but we also look at the heuristic. Did the heuristic work? Did it give us an approach that others would have used? And either we improve the heuristic or we can delete it, we can can it. Let me get a little less theoretical. Let's try this again with x squared minus 4. Let's try using our heuristic. So I would start off with x squared minus 4, and I would understand that, well, the solution set for this polynomial is going to be 2 reals based on the discriminant. I'm going to notice that it's a quadratic binomial. Oh, I'm also going to notice that the coefficients and variable are perfect squares, and that the ask was to solve for x. So I moved to the plan stage, and nothing popped up at me, so I look at my list of heuristics, and I spot that I have my list of heuristics which says when there are perfect squares, try difference of squares. And I have a little bit more information about when to use this. I use this when the coefficients and variables are perfect squares, and then I have what to do. Solve mentally, you got this. Use the difference of squares identity, never use sum of squares. So it's everything that we just talked about when we create it. We now use that as part of our plan. So my plan becomes difference of squares. I write down the steps that I got from, the link that I have for difference of squares. For me, I just linked to Math is Fun. They have a lot of great sources for knowing the steps on how to do things. And then I'm going to take that and I'm going to try it. And so I take that x squared minus a squared, I replace the variables and the values, and so the variable x is the same, but the 4 becomes 2 squared, and I get x plus 2, x minus 2, and I get the answer. And the important stage we always want to skip, but we should never, is to look back at it. And it turned out to be the perfect solution because I went out to Math Papa and I saw that Math Papa also would have done difference of squares. So my heuristic worked for this problem. All right, now you give it a try. I'm going to try with completing the square method. So if you haven't done this method, maybe you've done I don't know, maybe you've done factoring using the diamond method. You might want to try that. But if you've done completing the square method, try this process with me. So the first step you're going to do is you're going to observe it. Think about over the past week or two when you've used completing the square method. What type of observations do you have? How efficient was it for you? When did you use it? What were the criteria that defined when you would actually use that method? Were there any warnings? Did you have to be really careful, when you used it? Did you have to really monitor your work? And when you're done, come back and I'll continue. Okay, so for me, my observations, I was, again, over this week using completing the square method to solve about 20 problems, and my experience was that my efficiency and accuracy was very low. I kept forgetting to compensate, or I'd forget to include the GCF in the compensation, and then on top of it, you have to then do the square root method to actually get to the solution. I found that there's always another method that worked better for me, and however, I realized, the criteria when I really do have to use this method still is if I'm being asked to put the formula into vertex form. Okay, so then after I observed it, I'm not sure, if your solution was the same as mine, and even if it wasn't, we can keep following along. We have Oh, I just put a little note for myself. I just bashed the completing the square method, and I'm assuming I'm going to have a lot of mathematicians coming out angry at me. But it's a great method, for understanding the geometric proof, for understanding how we get to the quadratic formula. But for me to use completing the square method for solving day-to-day problems, it's not a heuristic for me. So my heuristic when I create it ends up being, I'm only going to use it for the vertex form. And, I'm going to use the completing the square method. But the main action I want to focus on is that I'm going to carefully monitor my accuracy, because whenever I do have to use it, I tend to make errors. And I'm going to avoid it if at all possible. Like, even if I have to get the vertex, I'm going to use negative b over 2a from the standard formula to get there. And the name I gave it is avoid complete the square, but for vertex form. I almost was going to name it avoid completing the square at all costs. That was going to be my heuristics. All right, and that's that. So I'm just going to go over this one really quickly to just show there's different types of heuristics. And this is a kind of like a dirty frugal tree, a heuristic that I created. And it's a way that I use to group all of the polynomials. And what I did was I created a heuristic that was called the polynomials that are obvious. Then I created another heuristic, the polynomials that are insane. And my last one is everything else. And so the criteria and the constraints for the polynomials that are obvious, it's just the same ones, again, that we're looking at with the understand phase. And I noticed that with polynomials. It's always the same set of criteria helps us make decisions on which method we should use. But what I notice is that, if all of those are easy to work with, well, then the polynomial is going to be really easy to work with. And what I mean by that is, if the solution set is real, if the coefficients are small or perfect squares, if the degree is quadratic or smaller, or well, I guess it can't be smaller, but if the number of terms are trinomial or smaller, well, then I know that this is going to be really easy. And the opposite of that is the ones that are insane. So there I mean like a complex solution set, or the coefficients are large and prime, the degree is greater than quadratic, the number of terms are 4 plus. Well, then I know that I'm going to have to really slow down, be cautious, and use some of the more complicated methods. And then there's everything else. And, the reason I put everything else last is because the criteria was harder to define. It's kind of that middle ground. So the polynomials that are obvious, I find that I always use the square root method, difference of squares, factor, and I always do it mentally and I always get them right. So I just breeze right through those. The ones that are insane, I look for next. And for those, I slow down, I'm cautious, I monitor my accuracy closely. And usually I'm using the quadratic formula or Lowe's method first. But if it's 4 terms or more, then I'm factoring by grouping. And then if I can't solve it using one of those two methods, then I am using U substitution, which is also difficult. Now, if it doesn't fit into those 2 categories, then it's everything else, and then I can typically find an identity that matches the equation or simply factor. Sometimes I prefer to use Lowe's method over factoring. So I hope that gives you an idea, just for you to not use this heuristic, but for you to see how heuristics can be created to help you solve problems. Now, you probably used lists before you were introduced to heuristics, and I just wanted to add that definitely keep using your lists. They're great. One of my favorite lists for polynomials is just the 5 approaches, the square root method, factor, identity, quadratic formula, completing the square. It always helps me when I'm thinking about the different ways I can move forward. The only difference between a list and a heuristic is that the list itself has additional information on when to choose each of those methods, and that's what makes it a heuristic. An example you can think of in your day-to-day life is, if you have a toolbox and you have a bunch of tools, that'd be like your list of tools. But when do you use each tool? Well, I actually, in my toolbox, I put little stickers on them every time I realize how I want to use a tool. So I've got one tool that has a sticker on it that says used for the bicycle. I've got another tool that has a sticker on it that says use whenever you need to fix the refrigerator. And so those are my little heuristics on my tool set. So I think that gives you an idea of that lists are still an important part of solving polynomials. But heuristics takes those lists and helps you more efficiently and more accurately make decisions on which to use each of those methods. Okay, so let's just digest everything that we learned. At a high level, we learned about heuristics. They're a rule of thumb for making decisions efficiently and accurately. We observe it, we create it, and then we use it. And the way we use it is in our normal Polya problem-solving process. We understand the criterion constraints of the polynomial. We then justify a plan based on those criterion constraints. If we're lucky, the answer pops out at us. If it doesn't, we turn to our list of heuristics. We then solve it. And then we look back to see if the heuristic worked, and if we need to improve it, we do so. And if it didn't work at all, we can it. All right, so what's next? I would say the great next step you could do is think of one heuristic from your experiences with polynomials. And once you've created one, start to practice using it deliberately to see if this works for you. I'm going to have a follow-up experience on constructing heuristics and seeing them applied more, and please keep an eye out for that. And so that's it. Thank you so much, and always my parting note, and I hope you have a wonderful math day.